The Bluetooth device is ready to pair.
Hello guys, hello everybody. Welcome to my YT channel. This is again I'm a singer eternal voice. Oh my god. This is an extension of the heat transfer of transport phenomena unit operations of in chemical engineering. Hello, welcome back again to this chemical engineering world. Oh my god. Okay, so we're gonna be having a discussion of one type of heat exchanger. Actually, there are a lot of types of heat exchangers, right? We have the first, the finned heat exchanger, the shell and tube exchanger, the tube, okay, heat exchangers. Okay, what else? The spiral heat exchangers, and we have also the double pipe heat exchanger, counterflow, parallel flow, something like that. It depends on the situation. What are the heat exchangers we'll be dealing with? Okay, ganon. Okay, I have a problem here. It's gonna be like this. Okay, okay. Liquid water flow at 200 degrees Celsius at the inlet of a double pipette exchanger. Okay, like that. With an overall heat coefficient of, so it says 700 watts per meter squared Kelvin. Okay, and counterflowing with steam with initial temperature of 25 degrees Celsius. Okay, the mass flow rate of water that goes into the double pipette exchanger is zero point 0.6 kilogram per second, and then the mass flow rate also of steam going into the double pipette exchanger is 1.2 kilogram per second. Okay, what are the values of the temperature of water in going out and the temperature of, what's this, steam in going out also? Okay, and also what's this, the steam and the liquid combined, the actual heat though, the actual rate heat transfer of the water and steam combined. Oh my gosh, how can we do this? Oh my gosh. Okay, so I think it's difficult, right? A little bit difficult. Really not easy. A little bit difficult shot. Okay? So how can we do this? I need to have my scratch papers first before anything else. Oh my god. Okay, and I have to show you how to solve this one. From my class, ano tadi ako papindo, fairness. Okay. Oh, andyan na. I'm wearing violet. So, I'm gonna have my pencil pen here. Let's choose black, red, green, blue. Okay. Let's try blue. Right? Bluer than blue. Okay. So, I'm gonna illustrate the double pipette exchanger. It's gonna be like this. Ganon. Okay. Oh my gosh! Like this, like this. This one. Okay. So, di ba siya parang blue, uy? Let's choose green. Okay guys, green. Let's check. T, oh my gosh. T, yes, it's okay. THINTCO. Okay. C, the small letter C represents the liquid water. Okay. And then, okay. And then the H represents the steam. Okay, like this. Okay, okay. THI meaning the steam going in with this temperature, THI, and then we have also the temperature of the steam going out also, which is THO. And we have a temperature of THI equal to 25 degrees Celsius. So 25 degrees Celsius convert to Kelvin, it's gonna be 25 degrees Celsius plus 273.15. How much is this? Okay. Calculator, please. Oh my gosh. This is 25 plus 273.15. This is 298.15 Kelvin. 298.15 Kelvin. So we have now 298.15 Kelvin is our THI, the steam that will enter into your double pipe heat exchanger. Okay. Then THO is the unknown. We need to solve this. Okay. THO. Ganun. So, unknown siya. So, this is letter A. Okay? Ganun. And then, we have our problems there. I need to look at the given and the data because this is the first step, right? To put the given and the data, or the second step after knowing what are being asked. Okay, and then we have the mass flow rate of the steam is gonna be mH is equal to mass flow rate, meaning mass per second. This is 0.6 kilogram per second. So we're gonna have our mass flow rate here. mH 0.6 kilogram per second. Okay? And now, since this is a double pipe exchanger, we need to do the pipe here in between. Okay, like this. Okay, guys? Okay, and then we have the liquid water flowing in to your double pipe heat exchanger. So I must draw here. So I must choose the red shot. Okay, so liquid water is C, right? Why C? Because it's cold. Okay, cold. And then H because it is hot. The steam is hot and the liquid water is cold in here in this problem solving. Okay, something like that. Okay, and you don't have to be, to be literal. Just only assigning the letter. Okay. Okay, this is liquid water C going in. So this is TCI. And then liquid water going out, TCO. This one. TCI, liquid water going in, and TCO, liquid water going out. Okay, so with the temperature or TCI based on the given data in this corner, because I write the data, this is 200 degrees Celsius. Oh my gosh, 200 degrees Celsius, double of the boiling point of water. Okay, so our TCO is also unknown, so therefore our required P is TCO. Ganon. Required BTCO. This is the second required, and what is second? What is being asked in the problem? Okay. And then we have also the mass flow rate of liquid water flowing in our double pipe heat exchanger equal to, what's this? Okay, 1.2 kilogram per second. Okay. MC. Okay. What's this? 1.2 kilogram per second. This one. 1.2 kilogram per second is our mass flow rate of liquid water. Okay. So you must put here H2O as a liquid water, L. And I must put here H2O also as gas or vapor state. Steam is still a water here, but in gas phase and vapor phase. You got a point? Like that, okay? So there's no other component except all are water. Okay? So we have now an analysis that it's gonna be in equilibrium with each other because these are all water. Only the phase changes are here. Liquid and gas. It's gonna be evaporation and condensation. Right? Okay. So, ganun siya. And then, our overall convective heat transfer coefficient is, what's this? Okay, 700. And this is the capital U. You get the point? Capital U. Okay. So, capital U is equals to 700 meter squared Kelvin. Okay, this guys. Guys, take note that this is for the convective heat transfer coefficient. This is not the thermal conductivity or the thermal diffusivity or the thermal diffusion coefficient under conduction. Okay, because this is convection. This is liquid and gas. Okay, heat transfer through convection is the heat transfer from a surface which could either be a solid or a stationary fluid moving to a fluid molecules. The movement of the molecules through fluid, liquid, and gases. Okay, ganun siya ha. So we should remember that also. Okay, the definition itself. Okay, now our specific heat capacity. Now guys, since this is water, okay, I told you to memorize the water, right? Because it's very easy. Or it could be given in the problem. Okay, but if there's no given, then you must assume that it's gonna be at 4 degrees Celsius, just like the density of water, something like that. Okay, for example, the density of water at 4 degrees Celsius is 62.43 pounds per cubic feet. Okay, 1 gram per ml, 1 gram per cubic centimeter, 1,000 kilogram per cubic meter. Okay, ganon. The latent heat of vaporization of water, vaporization meaning a change from liquid phase to gas phase. So it's gonna be 2,260 kilojoules per kilogram. And then we will say also 40.8, okay, kilojoules per mole. Ganon. Get the point? And then if we talk about for the condensation, it's simply the reverse, the negative of these values. Get the point? And for our latent heat of fusion, 79.7. Ganun siya. Calorie per gram. Okay, this is the latent heat of fusion. Okay? Okay, the latent heat of vaporization, so it's different to the specific heat capacity because the specific heat capacity has the temperature in the denominator. You get the point? That's the only difference between the specific heat capacity and the latent heat of vaporization or any kinds of latent heat, because there's also latent heat of sublimation, latent heat of deposition, latent heat of condensation and vaporization. But the most common is the latent heat of vaporization and the latent heat of condensation. Okay, since condensation is the reverse, put only negative to the values of the latent heat of vaporization. And this is at 25 degrees Celsius already have. Okay, now, what is our specific heat capacity of water at standard condition? So even though the problem will not state, it's already 4,186 joules per kilogram degree Celsius. Okay, then if you try to make it incompatible, it's gonna be joules per kilogram Kelvin. Okay? Usually, you get the point? Kelvin mo ang capital T, ang standard yun niya dili Celsius. Okay? You get the point? Pero makonvert naman gyapon na siya ng Celsius if you try to convert that one by using Celsius plus 273.15. O, ganon. Get the point? So, ganun siya. So, specific capacity of the water, CH. Okay. CH is equal to 4,186 joules per kilogram Kelvin, right? Yes. This is for liquid water. Okay, now for the steam water in vapor state, the CM, no, this is the CH. This is CC, sorry. CC kay C man atong liquid water. Okay? You get the point? C. Okay, CC. And then CH here. Okay? Specific heat capacity of the steam is 1/2. Okay, of that it's gonna be 1,900. Something like that. So 1,900 joules per kilogram Kelvin. Okay, now if we multiply the specific heat capacity to the mass flow rate, we can determine the specific heat capacity maximum and the specific heat capacity minimum. You get the point? And we will be using the minimum side, not the maximum side. You get the point? Okay, so let's do first the calculation of our heat. Okay, what is our calculation of our heat? So here we need overall rate of heat transfer efficiency. Okay, is equal to the actual rate of heat transfer. Okay, between the two combined, and then the maximum heat transfer Qmax. You get the point? This is the Qmax. Okay. Qmax. So Qmax. So ano po pag-compute? Okay. It's there. Here. You get the equation number 2, we have also efficiency is equals to, you need to memorize this one, guys. Okay, because it will take you a very long time to derive for this. Okay, so 1 minus exponential negative NTU minus 1 CR. Ganon. Over 1. So there are two equations of overall efficiency in which you can solve for the heat. Okay? And you can solve also for the, Qmax. Now our problem, there's a lot of problem here because we don't know the value of E. We don't know the value of Q, the actual heat transferred, and the maximum heat transferred also. So 3, so 4. There are 5 equations here already. And the unknowns are 1, 2, 3. Q. Because we have only 2 equations pa, and then we have a lot of quantities, right? So we need another 2 or at least 3 like that. What I'm doing now is let's think the possible equations to be used or appropriate or suitable equations to be used in order we can solve what are being asked in the problem. But in here we are only have 3 quantities to be solved: the THO, the TCO, and the actual heat transferred, which is the Q. Okay, so we can solve that by having these formulas. So we can also have the NTU here because our overall efficiency. So number of rate of heat transfer unit, that is NTU. You get the point? So NTU is equal to the overall convective heat transfer mean. Right? I told you to compute for the C mean and the C max is very important here. Okay? Overall specific capacity at maximum side. Okay, guys? May nahitabo. Number 3. Okay, so we have the equation number 3. Equation number 4 is simply the relationship CR is equals to C mean, C max. Or, okay? Ang dami na nating mga equations. Equations, CR, C mean over C max. C mean meaning this is the overall convective heat over the overall convective heat transfer coefficient to the maximum side. This is C max. And CR is simply the overall convective heat transfer ratio. That's why it is CR. Or C maximum. In the vapor state and the water, very basic formula of heat energy that we learned from our water. And secondly, we have also to take down the, it's gonna be like that. Okay? So, having these two equations, okay, having these two equations, 6 equations. So equation number 5 will be like this. QC, which is the heat of the water, is equals to MC times CC times delta TC. Ganon. Okay. You get the point? Okay. This is gonna be like that. And then equation number 5. Equation number 6 will be QH MH CH delta T. Okay, ganon. This delta TC and delta TH. Do that by looking for our. So we have the drawing. We have the illustration here. Okay, so we have this drawing and we can analyze through our, diagram or our, drawing, right? Or illustration. So in here, delta TC, since it is water, it's the normal heat transfer that we used to understand. Something like that. C, okay. So delta TC is equal to, again, TCO minus TCI. Okay. Guys, we need to solve the TCO, then we cannot use this delta TC pa, even though we have the TCI in our inlet temperature for the cold water. Okay, then we have the delta TH. Delta TH also, look at it. So they are the same direction. So it's gonna be like this, THO. Okay, like that. Okay, so it's I minus THO. It's gonna be like that. So THI minus, so TH here. Okay, now since they are G of the water and the drawing, both of them will go inside the double pipe exchanger, right? So in our E is equals to Q over Q max, we can use the same Q in here. So in here, in equation number 5 and 6, we can create now equation 7 and 8. This one, equation 7 and 8. Guys, be patient. It's a Bachelor of Science in Engineering course, specifically Bachelor of Science in Chemical Engineering. Okay, because there's a lot of equations to be used, such like this, okay? Equation number 8, delta TH, okay? And then we can derive us like that. And sometimes, okay? Because we cannot expect our instructors to spoon feed as they go to the most important. Shout out Michelle Rivera and Russell Maramara for passing by in my live streaming, watching this Bachelor of Science in Chemical Engineering under Unit Operations Transport Phenomena heat transfer through convection by solving the heat exchanger parameters and the designing of heat exchangers in different industries. So we can say TCO. Algebra lang yun siya, guys. If you have the 7, linear magod siya. Okay? Delta TC is equals to minus TCI is equals to delta TC. Then by algebra, TCO. You get the point? Okay, you need to solve for the TCO. So delta TC is equals to, ako sa yung papason kay murag nihukot siya kilid. Nakakaloka. So, delta TC is equal to TCO minus TCI. And then, your problem, guys, required you to solve the TCO. So, of course, TCO is our required of TCO minus delta TC. Ganun na siya. Okay? Take note, ha? And then, muna na siya nahitabo. So, it's gonna be TCO minus TCI. So, TCO is gonna be minus TCI minus TCI if you want that one. Or you can say that one also in reverse. Imo siyang balihon, TCO minus TCI is equals to delta TC. So TC charot plus TCI. Kani siya. Okay? Kaya na naman ka nga. Delta TC is equals to TCO minus TCI. Pwede masana siya TCO minus TS equals to delta TC. Therefore, TCO is equal to, okay, delta TC plus TCI na siya. Kaya i-transpose naman siya. So this is our equation 9. Equation 9. Our equation 10, nakakaloka, ang daming equations. The same thing. Okay, THI minus THO equals to delta TH. So therefore, I can say minus THO is equals to delta TH. THO, then THI, then minus delta T. Imagine we have now 10 equations in this particular problem. 10 equations to solve for TCO, TCI, and the Q. Okay, guys. So 9 and 10 is very useful to solve for the TCO and the THO that ask for the problem. And the Q also here in the equation 1 is very useful to solve for the Q in which is being asked because we have only found the individual problem from this one. Equation number 1. Since we don't know yet one, go to the formula that we can use immediately. So let's check number 2. In number 2 also, and see, we cannot use directly. There are 2 unknowns. So guys, if you have so many formulas, try to troubleshoot which formula that contains this that in another formula that requires 2 or 3 unknowns. It's gonna be like that. Ayun yung pugsa. Okay? First, go to the formula that you can substitute more, and then you can troubleshoot what is being asked by one quantity alone. Like this. Okay, can we use 3 directly? Do we have the overall? Okay, sorry. And ang C niya, ang U to ang convective heat transfer coefficient. Okay, di ba? Ang dali lang makorect because I'm listening what I am talking. Okay? So, if you're listening what we're talking, it's easy to correct. For example, if I will say 40 times 4 is equals to 1,600, it should be 160. Okay, because you are listening what you are talking. If you are not listening what you are talking, then at the end of your speech, after 1 hour, you will never correct that one. Even though how simple is that? You get the point? That's why a good speaker listens for every word that he or she uttered on public. Okay, so that he or she can correct it immediately after a few seconds or a few minutes. Because if you try to correct it after 1 hour and your speech are already finished, then you are not listening and you are not hearing what you spoke. You get to understand? Okay, because you have the ears to listen in every word that you uttered. UTTE, I mean speak, spoke, okay, or delivered, something like that. Okay, so we have now, so this is specific heat capacity. I justify my mistake, right? Okay, specific heat capacity, and U is the overall convective heat transfer coefficient, di ba? Convective, ganun talaga. Okay, with intonation. Wow, convective. Wow. Di ba? Ang saya special with ano talaga, enunciation. Oh my gosh. Enunciation, ha? Pronunciation. Hindi yan pronoun. Pronunciation. Kasi wala man siyang U, wala man siyang O, ano, P-R-O-N-U naman siya. Pronunciation. Charot! Correct me if I'm wrong. Maybe I'm wrong. Baka may O yun. That's what I remembered. Because I'm not an English major. Okay? My gosh. Okay, now. C mean, we don't know yet. C max, we don't know yet. So let's try individually. The water, liquid water, and the steam. So liquid water, how can we solve for the C? So let's try first the CH for the steam, right? H steam. So we have the mass flow rate. What is the mass flow rate of the steam in our given data is equal to, oh my gosh, it's gonna be, I'll check the drawing. Okay, 0.6 kilogram per second times 1,900 joules per kilogram Kelvin. Okay, this is gonna be like this. Okay. Our mass flow rate of steam is 0.6 kilogram per second, then multiplied by the specific heat capacity of the steam, which is 1,900 joules per kilogram Kelvin. So we have now the value of, let's do the math. Okay, 0.6, gosh, 0.6 times 1,900 is equal to 1,140, and this is gonna be joules per second Kelvin because we're gonna cancel the kilogram. Get a point? Guys, it's very clear, right? In here, we need to multiply the mass flow rate and the specific heat capacity of the steam. Then we need to cancel the kilograms because that is in the numerator and the denominator. Okay, denominator. Denominator. Okay. So kilogram is now joules per second Kelvin. You get the point? Oh my gosh. Really? Yes, really. Okay. And now for the C for the liquid water. CC is equals to CC. E is the designation of our liquid water, the subscript. Okay? We are using the subscript. Man talaga siya. Okay? Ganun siya. Thanks for watching Mr. Dooms Lapos for passing by the FB live streaming. Okay, so the mass flow rate of the liquid water in our drawing there. My drawing is in my bed and I have to look at it every time I discuss to you guys. Okay, that is 1.2 kilogram per second. Okay, multiplied by the specific capacity of liquid water, which is equal to 4,186 joules per kilogram degrees Kelvin. Okay. Again, kilogram will cancel, guys. And then what's left? It's gonna be, okay, calculator, please. 4,186. CR is equal to C min over C max. So we can say C max is equal to max, meaning high value. C max is equals to 5,023.2 joules per second Kelvin, and C mean is equal to 1,140 joules per second Kelvin. And we need to divide this one, but this is the ratio of the specific capacities of the two, the steam and the liquid water ratio, meaning unitless. Because if you divide this two, all the units will become guys, CRC mean over C max, and substitute is equal to, I'll never cover the unit because they have the same unit. Okay, so 1,140, the 2 is gonna be, okay, so 1,000, this one. This is very useful, guys, in order we can compute for the overall efficiency. Okay, so that after the overall efficiency, we can solve that for the equation. But still, you don't have the NTU here in your formula. So how can you solve for the NTU? We need to solve equation number 3 because it involves NTU there. And we have the C mean, and it's easy to solve already. Okay, and then you have no area for this. How can you solve for the area? Remember, if you remember the parallel flow of heat exchanger, okay, we have also the solution that also always 100 ml. Okay, like that. If ml also the given in the problem, for example, percentage by volume of 25% by volume of ethyl alcohol, yung ganon, and 75% of that. You get the point? So, percentage by volume is equals the volume of the solute over the volume of the solution. Ganon. Since you have the solution, you can get the volume of the solution. Kinama kay percentage of the solution. Ganun lang siya. This is very useful in mixing and in producing products through liquid. So how you point? For example, you will produce ethyl alcohol. Computation. Small lang siya, production. Then you have to send to your, your neighbor like that. Then you will prepare that one by hand. Something like that. Then you have to pour water and ethyl alcohol like this, and you will mix using percentage by volume. Okay, like that. This is related to this. Okay, but in here, guys, ayaw labdain yung ulo because there's no given of the diameter, the length, and the centimeter. All you have to do is to assume 1 meter squared area. So we can solve that by NTA by assuming 1 meter squared area in equation number 3. Okay? Muna siya itong equation number 3. O, diba? So substitute, guys. Okay, from equation number 3, we have, ganun siya, chuba chuchu. Okay, equation number 3, MTU is equal to the overall heat transfer coefficient, guys, which is equal to 700. Given you sa problem, 700 watts. Okay, meter squared Kelvin. Area 1 meter squared, which is we assume because there's no given. Okay, and then we have the C mean over the C mean. C mean we already determined here, which is 1140. Okay, so substitute values. Okay. Actually, guys, this is not very difficult because the formulas are very easy to remember and very easy to memorize. It will matter only in the analysis part of how you solve the problem. Okay, because it doesn't require direct substitution. Okay, most of the times, we will just be lucky if that is direct substitution. Okay, but most of the problem solving, especially future examinations like chemical engineers board examination, like that, they let the examiners think, okay, to solve that particular problem, not by direct substitution, though have also, I remember, okay, but there are a lot of problems also that you have to think and a little bit above average. Padung na siya sa difficult, but dili gyud siya difficult. Okay, for example, out of 100, as far as I could remember, there are 150 questions. Okay, there are at least around 20 problem solving that very difficult to solve. Okay, then there are at least about 30 which is above average, and there are about mga mga 15 that is average, easy to average, and there are a lot also of theories, 50 questions of theories like that. Okay, but it is a rumble between the easy direct substitution and the theories. For example, what is the normality? Ganun lang siya. They substitute kami mo mga values. So, sa'yo kaya siya, di ba? So, under mo na siya sa theories. Okay, ganun may anak. Mga normality, modality, di ba? And then mga theories, siya, chupa, chuchu. Alat siya. So, muna siya may tabo. Okay, so imong ikuha ng mga theories, so nanadyo kay pundudaan, mga theories questions, imo ba siyang perfect, ganon. So if there are very difficult problems, wala mo makuha atas, nabuntos ka dito ato sa mga theories. You get the point? Mga relationship, what will happen to the velocity if we increase the area of the heat exchanger, ganonan. What will happen to the length? Will it double? Will it triple? Like that? If we increase the ganun siya, theory siya. Okay? And then katong mga kuan guys, katong mga Le Chatelier's principle. You remember that one in physical chemistry? Whenever a stress is applied to a system of equilibrium, the equilibrium will shift in such a way to reduce its stress. That's in 1801. No, that's 1801. Yes, discovered by Mr. Le Chatelier's. Okay, the scientist who discovered that principle. Okay, so the stresses there are pressure, temperature, volume, adding of catalyst, okay, exothermic reaction and endothermic reaction. You will given a chemical reaction like that, and then the question will say, what will happen to the system if we add number of moles in the reactant? A will shift to the right, will shift to the left, remain constant. Okay, removing the energy, exothermic reaction, ganoon siya. Diba dali na kayo i-solve? O dali kayo answer? If you know the theory and principles and concepts, especially if you memorize. You get the point? Ganon. Okay, going back. So U A over the C min. C min is 1,140. Okay. Joules. Okay. Now, I will advise you also, if you don't like memorization, then don't take chemical engineering. Because there's a lot of memorization. Or do not take medical courses, such as doctor, like that, physical therapy, occupational therapy. Because seems like that also chemical engineering, a lot of theories. Okay? So it's okay also if you are very, very intelligent in mathematics. But it's not perfect man po math. Okay? So dapat kusog jud kog memorization. Okay? Get the point? Diha jud magtalunan sa memorization. Okay? For me ha. Okay. So NTU. Okay, di masad ko mag-memorize kung di ko kasabot. Okay? My technique is I will read twice and then I will understand. And then before I memorize, I take the clue of the sentence and the acronym, something like that, and then I memorize completely. Okay? So that I will retain that in my brain cells. Ganun siya. Okay? Ganun siya ang technique, guys. Okay, what's my calculator, please? So, 700 times 1 divided by 1040. So our C mean is 0.614, no, NTU, 0.614. Oh wow, bongga. Okay, if we have now our NTU guys na equal to 0.614, the number of the number of rate of heat transfer sapid puntila. Okay, so we go back now to the equation number 2. Kaya naman tayo NTU and CR, and we'll substitute that here, the equation number 3. Okay, gonna be... So it's very lengthy, right? My gosh. It's very lengthy. But anyhow, okay, overall efficiency is equal to 1. But in here class, our equation 2, we need to solve first the exponential raised to the power negative NTU 1 minus CR. We need to solve this first and then go back again to the original equation and then compute for the E so that it's easy for us to simplify, right? Okay, let's solve for the CR muna siya. Ano na tayo CR? Then, okay, direct substitution na. Okay, 1 exponential. Okay, NTU is, ano guys? Wait, nawala man pa sa screen. Woo! Okay, exponential. Kaloka. Exponential NTU. Ang atong NTU guys is, pila pa ito na-compute sa NTU. Okay, 0.614. Then 1 minus CR, our CR there, already computed also. It's in my bed. 0.227. Okay. And then over 1 minus CR again is 0.227. Times this exponential negative 0.614. Like that, 0.227 like this. Okay, this is the efficiency, guys. Okay, we only substitute the quantities that were already solved, and this is from our equation number 2. Okay, now compute for the efficiency. Calculator, please. Okay, ganun siya. So, okay, so 1 minus 0.227 is equals to times, okay, 0.614 equals to this negative, right? So exponential 0.474622, and this is negative. Okay, now scientific calculator, shift exponent, okay, negative 0.474622 is equal to, this is 0.622, okay? Okay, low-bat microphone, I need to talk by my mouth. Charot! Okay guys, nakakaloka, di ba? Okay. Okay guys, I have 0.622 here, ha? Sa in here, in this equation here. I need to compute first the exponential negative NTU, okay, 1 minus CR, so that I can substitute that directly here in our equation. So, it's gonna be like this. Okay. Efficiency is equals to 1 minus 0.622 over 1 minus CR. Kinapa man na siya CR there guys, so 0.227. 0.227 times 0.622. Okay, muna na siya guys. Substitute everything sa E. This is our overall efficiency over the rate of heat transfer. Okay? So if we have this, we can easily solve, right? Okay. Now, 0.227 times 0.622 is equals to 0.494 minus 1. Okay. Is equal to, okay, 0.8588806. So 1 minus 0.622 is equal to 0.378. Then overall efficiency will be equal to divided by 0.858806. So therefore 0.44015. So this is our overall efficiency na. Okay? So guys, we have the overall efficiency. We have the value of the CR. Here, the ratio. And we have also the value of our NTU. Okay, it's in here. Okay, NTU. Nasaan yung NTU? It's here also, 0.614. Okay, now it's about time to solve for the Q and Q max. Okay, so efficiency Q over Q max in equation number 1. We will now use this in this equation from equation number 1, and then we can compute now for the Q here. Okay, so Q here in algebra is equal to the overall efficiency times the Q max by crisscross multiplication. Okay, so Q is equal to the E times Q max. So this is our equation number 11. Wow, bongacious. Equation number 11 is equal to Q is equal to overall efficiency times the heat maximum. Okay, like that. How can we compute for the heat maximum? See, okay, if we compute for the Q maximum, we need to consider the C max, the specific heat capacity of the max. And we have here already the C max, right? Okay, now C max, which of the two, the liquid water or the steam, has the C max? It's gonna be the, here, it's gonna be the liquid water is the C max. So your Q will be basing on the Q max, on the liquid water. So you will say heat of the liquid water, or QC is equals to MC, right? And then times specific heat capacity or the C max. Then gano'n siya, chuba chuchu. Okay? Times the temperature. So what is the temperature here in the C max? Since this is already C max, our temperature gradient will be basing now here. Okay? Since our liquid water will enter here, and this is a counterflow, right? Counterflow, okay, double pipe heat exchanger. We don't care now for the outlet temperature of the liquid water. We will care now for the temperature of the steam that will go in. You got the point? Because the temperature of the steam that will go in here in the inlet, okay, will equal to the temperature that will also go in the liquid water. So it's in equilibrium with each other, combined. Okay, temperature gradient. We will use these quantities, not the TCO and not the THO. For the computation of the Q max, again, Q max is equals to the QC, which is the liquid water. Why? Because liquid water has a high value of specific capacity compared to the steam. That's why we call that as a C max. So Q max is equals to the mass flow rate of the liquid water plus the specific capacity of the liquid water, or the CC, times this delta TC, which is equal to TCI. Kani siya ba? Okay. Pero you need also to analyze. TCI ba siya or THI ba? So what I'm telling you, it's gonna be the TCI and THI. Analyze the two, which of the following have a higher temperature. Because the theory and the concept of heat transfer, the driving force is from high temperature to lower temperature. So take note which is higher here. So it's gonna be the THI because that is steam. Okay, steam is hotter than the liquid water originally when it goes there because it was not heated yet. Common sense. Okay? In the inlet, the water is still flowing man siya talaga siya. So it's not necessarily mean that it's already hot pa. Wala pa man siya isulod dito sa iyang kuan. Okay? So that's why we need to consider THI. We need to say delta TC, which is the driving temperatures or the temperature going will be equal to delta TC is equal to THI, the temperature inlet of the steam, minus the temperature inlet of the liquid water, because the steam is hotter than the liquid water that will go in the double pipe heat exchanger in a counterflow. You get the point? Because maybe you will be, reverse problem. If you reverse something wrong, if there's a negative, it will become positive, and your value will become already positive, and you will be wrong also. Okay, so be careful with the sign. Just take note, always from the high temperature to the low temperature. That's why THI minus TCI. Ganon. Okay? You get the point? Because in fact, these two are going in man siya. Diba? THI going in. TCI is going in also. It's not going out. The going out is the THO for the steam. So this is correct. Okay? We need to consider the inlet. Kaya nisud ba siyang duha? Ma-equilibrium siyang duha. Okay, ganun siya. So your Qmax will be, okay, Qmax is equal to, okay, CC, okay, MC times delta TC. This one equation, ha? Okay, and delta TC mo na itong giingon. THI minus, okay, TCI. Okay? All are inlet. In a counterflow, all are inlet. Ganun na lang. In a counterflow, double pipe heat exchanger, okay, inlet good siya. Okay? For the maximum heat energy. So, memorize this one specifically for this type of heat exchanger. Because the other types of heat exchangers also another formulas. The same formulas to be used, but there's a difference in the theory and the formulas to be used. But the concept is just the same. And you have also to memorize the formula of the spiral heat exchanger, the shell and tube heat exchanger. There's also a little bit of formula, right? Remember our first example is have also the temperature log mean is equals to delta T1 minus delta T2 over the logarithm of delta T1 over delta T2. And our delta T will be also the delta TH hot minus delta TH cold. So there's this difference, and our Q there is not the same here. The Q there is U times A times delta T. Okay, this is TH minus T of the cold. Ganon. Diba? Differential siya kaayo in fairness, and you have to memorize the specific formulas, ha? Ayaw girambol-rambol. Okay? Ganon siya. So, our flow rate of the liquid water is 1.2. Oh my gulay. Specific heat capacity of water is, yes, of course, 4,186. And, okay, and our delta TC is THI. Guys, THI is, temperature is 298.15. Okay, 298.15. It's in here, our THI, see? 298.15. But I forgot to convert in Kelvin the TCI. No problem. We'll just add this also plus 273.15. Okay. So, 200 plus 273.15 is equals to 473.15. So, ganun siya. So, okay. 1.2 times 4186 is equals to 5,003.2. times 298.15 minus 473.15. Oh my gosh. So this is negative 175. So our Q max is equals to times 5023.2. So it's gonna be 175 times 5023.2 is equals to 8760. Okay, and then convert. Okay, 1.2 kilogram per second times 4186 joules per kilogram. Okay, Kelvin times, okay, 175 Kelvin, cancel. So we have 879,060 joules. Okay, like that. So this is our Q max. So this is our Q max, guys. Take note, negative siya. Our Q max is negative. What this means? Again, this is exothermic reaction, meaning the heat is being released to the surrounding. You get the point? So if you have the process, if you have the system, okay, like that, and then we have the system will release the heat to the environment or the surrounding, then it's gonna be exothermic, that's why it's negative. If it is passive, it is endothermic. Okay, but if in the examination in the future, there's no sign, okay, meaning to say, it will be labeled in word. For example, like this, 879,660 joules at exothermic reaction, or 879,060 heat released to the surrounding. Okay, it's understood to be negative. Then if no stating the English, okay, it would be fine putting negative here in the value. You got the point? Again, okay, the value we obtain is negative. Okay, if this is negative, no need to say the words in English because it's understood to be in exothermic or the heat is released. But in examination, if there's no unit in there's no negative in the choices and still figure the same, you obtain, and there's an English that's specific. For example, this one, 879,060 heat released, like that. Or heat released to the surrounding. That means that's negative already. So that's correct. Even though there's no negative in the choices. You get the point? Because the theory speaks for itself. That it's just the same. Now, if it is positive, so this is endothermic reaction. Okay, endothermic reaction. Meaning to see also, heat is being absorbed. But for the positive, no need because there's no sign at all. You get the point? So it's not an issue. But for the negative, heat release is an issue because there's a negative. You get the point? Maybe the choices don't have negative and you don't have to choose because there's no negative figure. You get the point? That's also a trick in examination. For example, you solve for the heat energy and then A choices, girambol-rambol niya dito. Di ba mao ang figure? Muna siya makalisod. You get the point? Okay, letter A. Dito yung letter A nga, 879,060. Positive siya. Okay? Ganon. Let's say, positive. Then, ingon siya dito nga, heat release. Heat absorb. Hindi man na heat absorb ang kuan, ang negative. Heat release man na siya. So, wrong na to siya. Though, parihara siya sa imong answer. Di ba? Natuwa mo sa point. Muna, libugon dyan ka sa choices. For example, man siya, nakakuha kong negative. 879,060 joules. Meaning to say for this, guys, is heat released to the surrounding. Okay? So if the choices have like this negative, it's correct. Okay? Choose this if have negative. Now, if the choices there are all positive, okay? And then you get the negative. So the second option is to take note the word, the statement. It should be 879,060 positive siya, but the word will say heat release to the surrounding. It's just the same as negative in figure. You got the point? Okay? But the only difficulty there also, if they rambled also the answers from A to B to C to D, so most of the examiners will be confused. You got the point? For example, letter A, negative 879, B positive also, C, pareho siya tanan ba? Nandito na lang mag-matter sa statement po.
You get the point? Kaya usahay po dran ba? For example, negative 879,060. Ito ang letter A sa answer. 879,060 negative. Napadyo siya yung statement. Heat released to the surrounding. So this is the more correct. And technically the most correct. Okay? But sometimes magudili butang ag negative. You get the point? So the statement will speak itself because of the theory. Okay, you get the point? That means it's negative heat. You get the point? So ano na lang yung timanan? Heat released to the surrounding coming from the system, that is negative. Okay, na heat absorbed, okay, coming from the surrounding, going to the system, that is positive heat. Okay, you get the point? So, atong ikuan. So, example, if I have a coffee, okay, if I have a coffee is very hot and then it will become cold. So the heat is being released to the room. It was transferred to the room, circulated in my room. So that is exothermic situation. Okay, but if I have a cold juice talaga. If I have a cold juice and then I will try to contact that with hot water, and that is the endothermic reaction because it absorbs heat from the hot water. You get the point? Kay ang system nimo ang juice, nga cold juice, right? So mag-agad gyud siya guys sa system. So imong sabton ang system, ang surrounding, ang process. And then you troubleshoot what is the other term for surrounding. The other term for surrounding is the environment. Okay? And then specifically, if we refer to a certain habitat or certain location, for example, this is my room. So, I said surrounding. The surrounding will be my room. My environment will be my room. That is general. But specific is room. Okay? And in my system, for example, me is the system as a person. So, if I will release my heat to the room, so that is exothermic. You get the point? If I will absorb also the heat from the room, the cold from the room, and that is endothermic. Something like that, okay? You get the point? Exothermic and endothermic. Kasi nga na ganyan mga hit-hit, matter good siya guys, I'll tell you. Okay? So this one is negative 879,060, meaning this is exothermic reaction, spontaneous reaction, reversible reaction. Meaning to say it will proceed by its own. Okay, going back to its original form. Okay, ang katong mga irreversible, di man siya mubalik. Okay, so it will produce another byproducts, another chemical reaction, it will produce another residues like that, and it will never goes back to its original reaction or original reactant. So that's the difference. Now, if you try to have the negative heat also, and this is also enthalpy, because enthalpy is the heat content, is another term for heat, and then you can automatically say that your gives free energy is also negative. Okay? Now, you should also understand this term, the heat enthalpy, the entropy, and the gives free energy. Now, ang jowa ani higayuna, ang gives free energy and enthalpy are jowa. Uyab silang duha. Okay? Meaning kung mo negative ang enthalpy, mo negative sa C, gives free energy. So, mura silang magtiayon. Ang musibag niya na ang karirang entropy. Imo dyan natin manan permi that the entropy ang musibag. Kung mo positive to ang duha mo, negative ang entropy. Okay? You get the point? Kaya mo man permi sa thermodynamics, entropy gives free energy and enthalpy heat of formation. Okay? You get the point? And here also we get the heat Qmax is also under in the thermodynamics, right? And just what I'm explaining to you. Oh my gosh! Okay, this is our Qmax, bingo, or this, we can say this as is na lang Diyos siya, para walay problema. Okay, now, kinanaman taniining higayon na, we'll compute for the Q. Okay, Q guys, for the cold and the hot steam, cold water and hot steam, is, we need to compute this individually. But, using the same Q, because they are in equilibrium with each other, or steady state flow when they are passing in this double pipe heat exchanger in equilibrium with each other. So that's equal, something like that. Now, we use the same Q for both liquid water and for the steam in this equation. That's why when you solve for the Qmax alone, the Q for the two is just the same. For computing the the THO and the TCO that we are asking for. You get the point? Something like that. Now, if we have the if you have the Qmax, then we can solve for the Q, which is the required number 3 in the problem. So Q is equal to the efficiency that we also computed a while ago, which is equal to, where is that? Oh my gosh. Where is that? Okay. Ang ina ko nawala siya, in fairness. Okay. Ang atong E, okay. My gosh, ang atong E, asa naman to? Nawala. We solved that already, right? Okay, ang atong, this one. This is our E, right? E is 0.44015. Then substitute that here, this equation. Okay, Q is equals to E times Q max. And we have already the value of Q maximum, right? Oh, it's very easy to solve now. Okay, go back to the equation number 11. Equation number 11, to compute for the heat, which is only Q, which is that it's the heat of the liquid water and the steam. Okay, let's try now. Equation number 11. Wow. Equation number 11 is equals to Q. Overall efficiency, 0.4415 times Q maximum. Our Q maximum is equal to 879,060 joules. Okay. Now, muna na siyang atong Q. Take note. Okay. Let's do the math. Okay. 0.44, my gosh. 0.4415 times 879,060 is equal to, okay, 388,105 joules. And this is our heat. Okay. Guys, this is our heat, guys. No. Ano? We need to solve individually man ang iyang kuan, THO and TCO. So where is our, we will use now that here. Oh my gosh! Grabe, taas kayo siya computation. Okay? So we will use the equation number 9 and 10 to solve for the THO and the TCO. We already computed for the Q, bingo. And we have still 2 to compute well. Okay, the TCO is equal to delta TC plus TCI. Okay, we have the delta TCI, but we don't have the delta TC. How can we compute for the delta TC? Again, by the equation of the heat. But this time, we use the heat as Q na siya, which is in equilibrium. So, let's say this is for for liquid C. Okay, so QC but equal to Q. Okay, QC equal to Q. Okay, QC equal to Q, or Q alone is equal to, ganun siya, MC CC delta TC. Alright, ganun siya. Now, in this equation number 9, we have the delta TC here. So, delta TC is solve for the value of delta TC in terms of algebraic expression. Okay, now, the delta TC from here, is equal to Q. Okay, so Q over MC CC. Is then substitute that here. So Q delta TC is equal to Q MC CC. Okay, this value of the delta TC here will be substituted to this value here. Okay, and then since we know there are a lot of quantities were already solved, then bingo, we can compute for the TCO. Let's try it individually. Okay, so equation number 9. Bukas! Ang hirap kumita ng pera! Okay? TCO. Guys, I tell you honestly, ang hirap kumita ng pera. TCO is equals to delta TC. So will now become Q over MC as CC. Kaloka? Q MC CC plus TCI. Okay, this is from the equation number 9. Okay, check individually. Check. Okay. Okay. Q, check. We have the value of Q. MC, we have the mass flow rate. Check. We have also specific capacity of liquid water. We have also check. Plus TCI also of the liquid water, which is in the inlet. We have also check. Now, bingo. We can solve for the TCO. And now, let's substitute values. Okay, ganon. Okay. TCO is equals to, ang hirap. Ay, kutas. Q is equal to, is our Q. Kakaloka. Kaloka naman kayo. So, Q is equals to, okay, tapos na guys ha, 0.44, okay, and then Q max, 879,060, so pila atong Q, so 0.44015 times 879,060, okay, so we have 38 talaga siya, okay. This is our heat here, substitute, okay? So, 38, 105 over mass flow rate of the liquid water, 1.2. Okay, the specific heat of water, 14186. Okay. Uy, nakakaluka. Okay, I will show you. Okay, plus TCI. Okay, TCI is, ano siya, di ba, minus na ako ganina ang TCI, 473.15. 473.15. Now, take note, guys, your 388,105 joules, your heat, this is in joules, but your specific heat capacity is in joules per kilogram, so it's okay, no problem. Okay, it's joules per kilogram. I thought it was kilojoules. So joules over kilogram degree scale, it will be fine. Okay, we can compute directly because the joules will agree, the heat in joules will agree to the specific heat capacity joules there, so no problem. We don't need to convert. Okay, so ganun siya. So ano siya? So let's do this. Okay, 4186 times 1.2 is equal to 523.2, so 388, 105 divided by 5023.2 plus 473, okay, 777.26 plus 473.15. So we have 550 degrees Celsius, our TCO. Oh no, not Celsius, Kelvin, because we convert that already to Kelvin. Okay? 550 Kelvin. Oh, what is itong TCO here in our drawing of our illustration? We can put now the temperature of the cold water in going out is 550 Kelvin. Okay, so 550 Kelvin. Muna na siya ang counter sa TCO. Na ang THO na po. Okay, THO. So, ano na po ito sa usa? Okay. So, asa naman ito itong equation number 10. This one. Equation number 10 is THO is equal to THI minus delta TH. Now, this delta TH coming from the QH, MH, CH, delta TH. Solve for the value of TH in algebraic expression. Then we can obtain, okay, see, I have to illustrate that here. So, QH, MH, CH, delta TH. Then delta TH is equal to QH or simply Q over MH, CH. Now, our delta TH is here. Q over MH, CH from equation number 10. and do the algebraic mathematical expression. And you can get the delta TH. And then substitute this to the equation again in 10. So it will become now as equation number 10 here, class. Okay, it's now become THO is equals to THI. We need to substitute directly the values. It's okay also. Our THI is 298.15 Kelvin. Okay, so that is minus 298.15 Kelvin. And then it's gonna be the Q. Our Q is 38105. And our mass flow rate of this steam is 0.6. Okay. Then the specific capacity of the steam, which is equal to 1,900 here in our given a while ago. I showed it to you a while ago. So this is 1,900, like that. So we can solve now for the THO. Okay, like that. Very, very far. Maybe you cannot understand too much numbers. Right? Oh gosh. Okay guys, muna siya nahitabo karong higayon na. Okay, so THO will be equal now to, okay, so 0.6, okay, 0.6 times, nakakaloka, 1,900, okay, 1,140, oh gosh, 388,105 divided by 1,140, right? Okay. Then 340, asa naman ito niyang pares? Okay, muna siya nahitabo karong higayon na. Okay, minus 298.15 is equals to 43 degrees Celsius. Okay? Ano? Kelvin, sorry. 43 Kelvin ang atong THO. 43 Kelvin. THO 43 Kelvin. Now, akong i-explain ha. Ang THI is coming from dako siya, diba? 298.15. Himo na lang siyang 43. Why it reduces its temperature? Because it will contact to the cold water, which is originally at 200 degrees Celsius or 473 Kelvin. That's why, okay, that's why it will become less, the temperature of the steam will go out. It will become cool. Because our water initially is very 200 siya. Okay? 473 Kelvin. So it will transfer the heat of this liquid to the steam, and then this steam will become cooler na in going out. So that's why THO is 43 Kelvin from 298.15 Kelvin. Now I'll explain also the TCO. Why? The TCO is 550 Kelvin. Okay? Like that. So we have from also 473. It will go high also. Why? Because when this water is going out, there's also the steam here that's very hot. You get the point? And then the outlet of this heat exchanger is in the corner man siya. Okay? And then if the water will go there, somewhere in the corner until the last, of course, the hotness of the steam will also combine to the temperature of the water here. That's why the 473 Kelvin also will go up to 550 Kelvin. Will increase na siya. You get the point? Because naman siya there is a corner. So there's a transfer of heat. That's why this is heat transfer. You get the point? That's why this topic is heat transfer. As you can see, the heat is being transferred, right? And the temperatures is our evidence that the changes of the temperatures. For example, the temperature of the hot steam initially, okay, will become now 43 out of, let's say, 298 here, because it transferred also the temperature coming from the liquid. Ganun siya and vice versa. Now, get the point? And now, their heat individually will be the same because they are in equilibrium. You get the point? Muna siya hitabo. Okay, so very clear. So our answer now is the outlet steam temperature is equal to 43 Kelvin. The outlet temperature of the liquid water is 550 Kelvin. And our Q, the actual rate of heat transfer, the actual, is equal to 388,105 joules ang actual. Okay, and our maximum is equal to, muna na siya, 879,060 joules. And then, no need to explain why taas ang Q maximum because that is maximum. Right? No need to explain the comparison between the Q alone in equilibrium and the Q maximum. Because sa word pa lang itself, klaro na siya, madako siya. And then, it will be surprising if your Q max will be lesser than your Q. And that will be subject to debate. You get the point? If I will get a Q which is higher than 807, if I get a Q max which is higher than 879, lesser than, that is not a correct answer. Here, our guys, Q maximum, 879, taas good siya, di ba? And then our Q is 208, 105. Okay? Nga nung nigamay ba ang hit niya, Sir Sotero, sa actual? Because tanawar ako din yung, okay? Okay, tanawar ako din yung transfer. Okay, ang yung heat gradient, temperature gradient. Okay? You get the point? Ang steam, nigamay ba siya, 43. Nigamay po siya ang yung kuan, TCO. So expected na yun na siya, ang yung Q is always lesser than, actual Q is lesser than the Q max. You get the point? Charot. Okay, thank you so much. If you understand this heat transfer computation, what's this? Heat transfer computation or designing of a double pipe heat exchanger counterflow, like that in heat transfer, in under the study of unit operation, okay, transport phenomena, heat transfer, like that. In chemical engineering. Okay, you can also subscribe my YT channel if you want for more. Okay, and then you can also comment down below in the comment section, and then you can subscribe my YT channel if you like also. If you are really interested about academic information about pure sciences, chemistry, physics, chemical engineering, planetary science, like that, biochemistry, okay, this YT channel is perfect for you. Oh my gosh. You can also click the notification bell for some newest updates of I'm a Singer, Eternal Voice. And I can also vlog and live stream occupational safety and health and some personal vloggings also. It depends on the situation, okay, on the particular moment that I will do the vloggings and live streamings, okay. And I can also have sometimes singing songs, okay, different genre also in singing, okay, during my day offs. I have to do that also, so it's gonna be like that. Okay, my world as an OFW will always be revolving to that kind of, habits, HOBBIES, or shall we say, pastime. Okay, you get the point? Okay, thank you so much, guys. I have to end this live stream and vlogging because I have another appointment. This is again, I'm a Singer, Eternal Voice. Bye bye. God bless everybody and stay safe. Mwah, babush. Da, 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 da.